Hello, welcome from my side. I'm Thiex. I'm from the same company as not Gregor, but Gregor, who was just two before me. And I'm very happy to present to you the EvoLand project, which has quite a lot of connections to what Tom mentioned before, but also what Gregor mentioned, so you will be able to make some connections. The EvoLand project itself stands for the evolution of the Copernicus land monitoring service. And I'm going to present to you the project a bit in the first part and the results, and then what we did on the public dissemination of the results. The project itself is a Horizon Euro project that started a bit more than 2.5 years ago in January 23, and it's coming to an end this year. And the main goal of the project is to enhance the quality and efficiency of the CMS data sets. CMS is the Copernicus Land Monitoring Service, and it's a vast mix of different products describing land cover changes, land use, vegetation states, water cycles, and as we heard before, the first iteration of those products is also now integrated in the CDSE. And within our project, we now want to develop new methods and products to create the next generation of those products. One key aspect when doing this, what's important for us is to preserve the continuity of the already existing products, but with developing those further to keep the service modern and attractive. So to improve the quality and also the efficiency in how we generate those products. One cool thing about the CMS products, they are free of charge and can be used for any purpose, and they have global coverage. The project itself, we broke it down into 4 steps: the requirements, the methods, prototypes, and operationalization. And we kind of tackled each of those blocks separately by different partners, and then tried to connect those. Within the requirements, we started very early at the beginning, connecting with different stakeholders from user and policy to get to know what their requirements would be, what they would need from products to be able to make their decisions. But then also with the methods and prototype developers to ask them what are their needs on the infrastructure to create such products, and what data sets in situ and EO data and ancillary data do they need. We did this by meeting with the stakeholders, but also by distributing surveys within the consortium for the prototype developers to get a good picture at the beginning of the project. What do we actually need together to create the most valuable products? The methods, they were developed and then used within the prototypes to create the results. The prototypes itself, they are spread over 5 different themes, from agriculture, forest, water, urban, and general land cover. And then, despite us developing prototypes in the project, we try to always keep the operationalization in mind, so that at the end of the project, we have prototypes where we have a clear path forward to how can we produce them on a large scale in a cost-efficient manner, how can we bring them into a workflow where they can be automatically, regularly created and create value for the users and the policy makers. These 4 steps we actually did 2 times. So we split the project into 2 phases with the idea that we learn from the first phase and improve in the second phase from what we've learned in the first cycle, so that we can then, for the first iteration of our development, improve the infrastructure, improve the data sets we use, improve our algorithms, and come to the best results. Additional to these 4 steps you see towards the end, just next to the green arrow, we have a public results portal, which is coming out next month, and that will still become later important. Looking a bit more at the different methods we were using within the projects, you see them here. We were looking into using novel EO and in situ data. And as mentioned, we checked with the prototype developers what kind of data they need, and brought HR data and in situ data in their workflows to improve the quality and the resolution of the results. Novel IT, here we're looking for some scalable, stable, and cost-efficient cloud infrastructure, also with the operationalization in mind. And what we did there was something that was also already a bigger slide before. We recommended the prototype developers to test and quickly iterate on the prototypes locally, but then once things are working, to scale it up, move to a cloud infrastructure. And there we are using for quite a lot of prototypes OpenGeoHub within the CDSE. We also have, to some degree, AI incorporated to reduce the size and the complexity of our data sets to make it easier for downstream applications to use those data. We're using data fusion to improve the spatial, spectral, and temporal resolution of the existing data set. We want to use continuous monitoring so that we come from currently multi-annual or annual products to products that are created maybe every month or even on a higher temporal resolution, especially in the fields of the forestry, urban, and land use changes. And then biomass mapping, where we use new methods to map above ground biomass and also across primary productivity in croplands and grasslands. As mentioned, we have these 5 different themes where we have 3 prototypes, each in the agriculture and the forestry domain, 2 in urban and general land cover, and 1 in water. And in total, we have them spread over 8 prototype sites that you can see here to make sure we have a very different terrains and land use, land cover types in our prototype sites, so that we are sure our algorithms work in different climates and with different land covers. To give you a bit of an idea what to expect at the end of the project, these are unfortunately still the results from the first cycle, because we are just wrapping up the second cycle, but one example from each of those domains of what we will share with you later. This is the C1, C2 on forest disturbance prediction, and what we do in this prototype is that we use the data from our C1 prototype that gives location and time of forest disturbance, and then try to analyze what actually caused this disturbance. And all of that at a 10-meter resolution. This is an example of C6, which is mapping of small landscape features. And we do this on a 5-meter resolution. And afterwards, by comparing mapping of different dates with each other, we can also analyze a bit of the change of those small landscape features. This is an example of C7, which is improved water bodies mapping and the probability of how likely it is to find water on those locations. Here, an example of automated land use mapping and urban change. So again, we first map the land use, and then by comparing different dates and the mapping results, try to analyze what changed. This is also on a 5-meter resolution. And then the last example is an on-demand land cover mapping, where in the final results, we will have 9 forestry classes at a 10-meter resolution. Those of you who are familiar with the CMS products or also are from those domains will now say, but those products are nothing new, and I agree with that. But the idea or the main goal of those was to either improve them in a spatial or temporal dimension, or in the speed and efficiency where we can create that. And for all of the products, we achieved either 1, 2, or all 3 of those. That now kind of concludes the first part, where I wanted to present a bit how we set up our project and what the results were. And now for the second part, that's the part you will especially like, Figure, because we made use of the CDSE for our results portal. Because when we had the need to disseminate our results. We want to make them publicly available. We want people to use them, to give feedback, to use them in their work. And there were a few questions that we asked ourselves. How can we actually reach a wider audience? How to make sure the project results are available after the project ends, because we don't want to just publish them somewhere and a few months after the project ends, things disappear. How do we provide the best interactive experience for the public to explore our results? And also something that was already mentioned today, do we always, with each project, have to reinvent the wheel? Do we always have to create a new results portal, or can't we take what's already there, improve it, and build on that? We researched, and as already hinted, we found we were successful with the CDSD. When we started the project, the CDSD was at the very beginning, so we didn't really know what to expect. But now, also as with Synergize, we are a partner in the CSD project, we actually had a very good idea of what to expect. But it's not a one-way partnership with us using CSD for our results portal. We actually also able to bring improvements into the CSD through the requirements we had within the EvoLand project. To be a bit more precise, we used the Copernicus browser, which is the graphical user interface to search, visualize, and analyze the satellite data. And what we did, we added a new configuration or new theme for the EvoLand project, and here we added all our 11 prototypes, including a small description per prototype. And also then for the data itself, for each prototype, different layers showing the data and describing the data or the visualization a bit more in detail. The Copernicus browser was actually exactly what we wanted from our results portal, a tool where we can visualize the data, where we can compare it, where we can download it. How did we do this? We were using an API, a service within the Copernicus database ecosystem, the Bring Your Own Prop API. And to use that, simply what we had to do was converting our data into cloud-optimized geotiffs. That was quite straightforward because most prototypes already had the results stored as TIFFs, so we just had to convert them into geotiffs. Then we had to set the bucket settings so that the service could access our data, as we had the data from the beginning of the project already stored on a CDSD bucket. That part was also very easy. And then for each of the 11 prototypes, we had to configure a collection and ingest the types so that the services we use for the visualization and the catalog requests knows on which date and for which location we have data. Why to use an existing solution? So why did we go down this way? We found it especially useful because we would get features beyond the pure viewing and download capabilities, something that we committed in the project to provide from our results portal. As you can see here, we have support for drawing of AOIs, for uploading of areas. We have the statistical analysis feature integrated, which is offered by CDSD, and that's something that we would definitely not have done if we would have just created our own small viewer within the project. Also, we can just make use of 3D viewing capabilities. We can create these super nice time-lapse animations. We have option to compare visualizations, to save visualizations, share them with other people with pins. Beyond those additional features that we kind of got for free, there's a few other advantages. For example, let us focus our time on the prototype development and on the data validation so that we actually were able to create better results. It also allowed us to be faster, which was especially important as our timeline on finishing the results and publishing them in the viewer was very optimistic when we wrote the proposal. Also, by using the Copernicus browser, we are using a tool that's already familiar to the EU community and people know how to use it. So there we hope to reach more people and get the data to more people because they already know the tool. And we know it's scalable and performance tool. The next steps, or maybe one last thing, all of this was very easy, took us not that much time, and the whole process is very well documented. So also if you have a project where you create EO data and you have a need to visualize it or to distribute it, we kindly invite you to consider going down such a way so that you don't always reinvent another viewer and another service to do things that we actually already solved years ago, but rather focus our time and energy in improving the data, in analyzing the data, and sharing the value we get out of that data. Within the project, we have a few things left. As mentioned, we just wrapping up the last cycle of the prototype development, so we need to ingest that data into the CDSE. And then next month we will publish the EvoLand theme within the Copernicus browser. And then until the end of the year, we have to wrap up the project and do some reporting. And with that, I thank you for your attention and I'm going to question.
There's a lot of useful particle messages taking on your bullet here. I didn't know you can build up these apps now in CDSC, right? You can just build up an app, basically, and expose it, and people can then, find the data and digitize the things.
I mean, we integrated it with the existing app, but that's possible. Everyone can bring his own data and integrate it there.
Okay, let's see the question from the audience. Quickly. Questions, yes, please.
Yeah, just a small question. Can you also access to the API? Like you want the polygon?
Yes, you can also send the polygon to the API and you get the same data back. We just use the browser because we are focusing in the results distribution more on the visual aspect of the data, but you could integrate it into your workflow, into Jupyter notebooks and get the same data back.
And one more practical question is when, let's say you have a data and let's say it's like few terabytes and you want to upload it to CDSC, you have to pay the hosting, right?
Yeah, that's connected to what Clara said, that there's some quite generous free resources, especially if you have ESA or European Commission projects where you can apply for this. And also now in the EvoLand project, we asked for the bucket and we got it sponsored by those sources. And I will first try to go down that way, and then that should cover already a lot of use cases.